Hi everyone, so today's lesson is on section 1.5, bar graphs and histograms. First we're going to go over bar graphs because I think that's what everyone's probably most familiar with. Bar graphs are used when you need to compare things between different groups or track changes over time. In this first example that I have here, you see a bar graph where we are comparing two things, or three things in this case. What you have here is party affiliation in 2012. And you have a bar for Democrat, a bar for Republican, and a bar for independents. And you can see the key here. Every single bar graph is going to have a key telling you what each bar represents. So this goes through April through May, and it looks like it's a poll, and based on these numbers, I'm going to say that this vertical axis is percents of those who are polled in each month. You look at this first one and you can see 2 under 30 and 1 over 40. So I imagine those are going to add up to be about 100%. And so you can see those changes over time and you can compare the three different groups. You guys are probably very familiar with bar graphs, and we're not going to spend a ton of time today talking about them because I know you've been using those more than you've been using histograms. I know histograms are new. So let's get to histograms. Now, histograms can be used to plot the frequency of occurrences in a continuous data set that's been divided into classes that we call bins. So what I have here is I have an example of a histogram of people not covered by health insurance in the year 1998, and that title is leaving out a few things that I'd like to add. So what this is this gives the percent of each state of people who are not covered by health insurance in 1998. So it's percent by each state. So let's take a look what one of these bins represents. Maybe let's use this one right here. What on earth does this bin represent? So first I see that on the x-axis, you can see that the bin goes from 16 to 17%. So this means this bin is 16% to 17% of people in this bin are not covered by health insurance in that year of 1998. Notice that I'm including the 16% and I am not including that 17%. And that's because if I'm looking at a data set and if you have exactly those bin numbers, you need to know which bin it's going in. Like if it's exactly 16%, why does it go into this bin right here instead of the bin to the left? And that's because we can include the left endpoints or the right endpoints, but never both. Most histograms cover the left side of the bin and include that left number, that lower percentage or that lower number, whatever it is, but sometimes they will use the right-hand side, and it should always tell you. The default is always to the left, though. If it's not explicitly stated, you should know that the left one is the one being included. Next, I gotta look at like how high this is. So if I'm looking at this is 3 units high. So that means in this data set, 3 states have between 16% and 17% of their residents not covered by health insurance in the year 1998. So it's incredibly thorough and a long sentence, but I need all of that information. I need to make sure I outline that it's 3 of the states because that tells me the frequency, it tells me how high it is. I need to make sure I highlight the 16 to 17% with the 16 being included. And then I always want to make sure that I am addressing this title here, the covered by health insurance in 1998. I want to make sure I know what it is. All right, so the first question that I have here says, which bar would include a state that has exactly 14% not covered? So let's go back to what we said about left endpoints being included. So for this question, it looks like I'm going to this bar right here. This would be the bin that has 14% non-coverage because it would include that left endpoint. So there it is. Now 2 says estimate the mean. Okay, so when I'm estimating the mean, again, this is going to be an estimate. But let's get a better idea of like how many states we're working with here, and kind of what exactly is in each bin. So I see from 9 to 10, I've got 4 states. 10 to 11 looks like 7. The next one is 2, 3, 3. Back up to 7. Then I'm at 4, 3. The highest bin here is between 17 and 18% not covered. Then I have several states that have a higher percentage that are not covered by health insurance. Looks like 2, 4, 6, 8, 10 of the states have over 18% not covered. So now, when I add up all of these numbers, I should note that I get 51 total data points here, 51. And that's because Washington, D.C. counts technically as its own state. So make sure that you are counting, that if you're reading states, don't assume it's 50, because sometimes Washington, D.C. counts as its own. So if I'm going to estimate the mean, the average, I can't get it exactly because I don't know what the actual data points are. But I can see, where my highest numbers are, and I can see that it's skewed to the right. So I'd probably pick anything from 14 to 17 maybe. I think that would be a good estimate. Anything from about 14% to 17%, I'd probably accept and say, yeah, that's a pretty good guess based on how that data is lying. But again, it's just an estimate. You could probably argue another estimate as well. Number 3 says, how many states have 19 to 20% not covered? How many states? So if I'm looking at this 19 to 20%, I'm looking at this bin right here, looks like 2. Now what if I changed that question? What if I added a 4th question and I said, what percent of states have between 19% and 20% not covered? Well, then I would have to take the 2, the frequency, and divide by 51%. And so then I would get that percentage, and 2 out of 50 would be 4%. So I'm going to say it's about 4%. It's going to be a little less than that, but it's about 4% because I know 2 out of 50 is 4%. All right, so let's take a look at some data, and let's talk about how we might make our own histogram. So here I have basic yearly student charges for room, board, and tuition in public colleges by state, and this is in the year 1994 to 1995, so I'm going to assume that academic school year. You can see that these are in ascending order, which is nice, and I can see that there's exactly 50 states because I can see it's an even number. So I'm looking at 50 states, 50 total data points, with Oklahoma having the cheapest charges and Vermont having the highest. So you can see I have a frequency table here where I'm going to display my data and do the frequency here. Let me move this down a little bit. So let's start counting. If I were to ask you what the bin width that I'm using is, I guess we didn't talk about that really on the last slide, but the bin width that I'm going to use is going to be $1,000. That's what I'm deciding here. See how that length is going to be 1,000 for each? So let's count how many is going to be in this bin from 4,000 to 5,000. I'm just going to use a highlighter here. It looks like I've got 4 total states there. So I've got 4 that I'm going to use. Need that to be 4 units high. Let's look from 5 to 6,000. So all the way down to Montana. All of those states. So if I count those up, that's pretty high. That's going to be 20 total states. If I take a look now at the 6s, don't forget this 1 down here. And then I gotta go all the way down to Oregon. That is going to be 9 total. And let's see, from 7 to 8,000. That's going to be 8 total. From 8 to 9, coming towards the end, that was 7 when I counted that up. And then 9 and 10 are 1 and 1. Easy enough, 1 and 1. So now I'm done with that data for now. I really just need this frequency chart so I can draw the histogram. So a few things that I need. I'm going to need a title for my x-axis. So this is where I'm going to have the total cost. It's in dollars. And I'm going to put in thousands. That way my x-axis doesn't get too jumbled. That way instead of 4,000, I can just write a 4. And 5, 6, 7, 8, 9, 10. I got to go all the way to 11 to satisfy that bin from 10 to 11,000. So I can get Vermont in there. I think that was the highest one. And now I see that the highest bin that I'm going to have to work with is this 20 right here. So I got to have something 20 units high, and then the lowest are going to be these 1s. So I think I'm going to go ahead and count by 5s. And I'm going to go ahead and title this axis right here as just the frequency, the number of times that it occurs. So I'm going to count by 5, count by 10s, or count by 1s, 2, 3, 4. I'm going to exaggerate the 5s though. So then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The way I exaggerate those 5s will make these bins a little easier to draw. And now I'm ready to go ahead and just draw them. So from 4 to 5,000, in this bin, I need it to go 4 units high. Then in the next bin, I need it to go all the way up to 20. And it's important that you try and make these as equal width as possible, since we are using equal widths. And all histograms should use equal widths. The next one from 6 to 7,000 is 9 units high, then 8 units high, then 7 units high, and the last 2 are both 1 unit high. So there's the histogram. I need a title. So this is going to be cost of colleges 1994 to 1995. And this is going to be room and board and tuition. It's going to be all of it. Ideally, the title would be, right over the histogram. So with the histogram, something that you can see right on the get-go from a histogram is the shape. Remember when we had a dot plot, we could do this. We could draw just a line right over the top, and I could see the shape. So you can see this one is going to be skewed to the right. I can't tell the exact median. I can't tell the exact mean or mode because I don't know the individual data points from the histogram. But if it's skewed to the right, then I know, well, we'll talk about this later, but if I was going to say, well, how does the mean relate to the median? That's a question that you might ask, like, is the mean going to be bigger or smaller than the median? Well, since the data is stacked on this left-hand side because it's skewed to the right, that means the median is going to sit over there most likely. The median is going to be somewhere over here in this bigger chunk. And since you have these data points sitting over here, that's going to pull the median in that direction. I'm sorry, it's going to pull the mean in that direction. So here's my median right here. These are going to pull that mean to the right. So the mean, because it's skewed to the right, is going to be greater than the median. And we're going to talk about that more on the last slide. So the next thing I want to talk about is a relative frequency histogram. So sometimes you get a histogram that tells you just the frequency, but sometimes you get what's called a relative frequency histogram. So it's a little different in that instead of giving me the frequency, it's going to give me the percentage, how often it occurs. So relative frequency is going to give the percentage. not the total number. So in a relative frequency histogram, you're not going to see that 4 of the states have a tuition from $4,000 to $5,000, or I should say a total cost from $4,000 to $5,000. What they're going to do is they're going to take that 4, divide it out of the total number of data points you have, which we had 50, and that's 0.08, or 8%. And so that's what you're going to see in the relative frequency histogram, is that 8%. Sometimes I've seen it both ways, with that height being literally the 0.08, and other times I've seen it as the percent of 8%. So I've seen it both ways. So let's go ahead and calculate those relative frequencies. If I have 20 out of 50, well, that's going to be 0.40, or 40%. 9 out of 50, that's going to be 18%. 8 out of 50 is going to be 16%. 7 out of the 50 is 14%. And then 1 out of 50 is going to be 2%. So notice in this relative frequency histogram, my x-axis is going to be the exact same as I had on the last histogram, just these heights are going to be different. So now my lowest is going to be this 2%. These are going to be my lowest. And my highest, instead of 20, is going to be this 40% right here. So when I'm drawing the relative frequency histogram, let's go ahead and on my x-axis, it's going to be, I don't want to use the highlighter, I'm going to use this. It's going to be the total cost again in dollars, and I'm going to put in thousands so that I can just have 4, 5, 6, 7, 8, 9, 10, and 11. And then on my y-axis, I'm going to say relative frequency. It's a little cramped. Relative frequency, and I'm going to go ahead and I'm going to go by 2s. So I'll go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. And then I'm going to erase this right here. Oh, maybe I'm not, because my eraser won't work. There it goes. That way I have a little more space. Let me draw this up. So 32, 34, 36, 38, and a 40. And I'll draw that percent sign here to help remind you that the relative frequency is the percents. And now I think we're good to go. So my first is going to be 8 units high from 4 to 5,000. Then this next one's going all the way up to 40 from 5 to 6,000. 40% of the states have a total cost for room-born tuition of $5,000 to $6,000. The next one's going to 18%, then 16%, then 14%, and the last one is 2% for the last two. Notice that the relative frequency histogram, it has the same shape as its corresponding histogram. So we can see it's skewed to the right. The only thing that changes is going to be the y-axis. It's the only thing that changes. Everything else is the same. All right, so for my last example, I've got a relative frequency histogram. You can see right here where it says relative frequency. It tells me that these are percentages. And notice these percentages are not in the percent, they're in the decimal form of the percent. So when you see these bars up here that go up to 0.25, that's 25%. So these represent onboard charges for singles 7-day cruise sailing to the Mexican Riviera from Los Angeles. So these are onboard charges for this cruise. So it says if there are 500 people on this cruise, find the total number of people who spent, let's do first, between $50 and $100. So if onboard charges were between $50 and $100, I'm looking at this bin right here. Now I need to know exactly how high that is. I'm going to guess, I'm going to say this is going to be 0.08 units high. So if it's 0.08 units high, That means 8% of the 500 people on board spent, I should say spent, past tense, between $50 and $100. I should not include that, and $100 on the cruise. So if I want to know how many people that is, I need to calculate what is 8% of 500. So I'm just going to take 500 multiplied by 0.08, and that's going to give me 40 people. For the next question, number 2, they're asking me the same question, just what about the people who spent between 150 to 200? Well, it's 0.25 units high, meaning I'm looking at 25% of the 500 people. So, in order to calculate that, I'm going to take 500 times the 0.25, and that's going to be 125 people that spent between $150 and $200. Now the last question, the third one. How many people spent between $250 and $300? So I'm looking at this bin right here. That looks to be about 0.17 units high. So I'm going to say 17% of the 500 people. So when I'm calculating that, I'm going to take 500 times the 0.17, and I'm going to get 85 total people. And there we go. A few really quick things that I just want to highlight. When you have a relative frequency histogram, let's take a look at all of these heights. And this is nice because I have a nice symmetrical histogram. So I can see from 100 to 150, that's 0.17 units high. From 2 to 250, that's another 0.25 units high. And from 300 to 350, that's another 0.08 units high. If you have done a relative frequency histogram and it's been done correctly, all of those heights should be equal to 1. When I add up 0.08 plus 0.17 plus 0.25 plus 0.25 plus 0.17 plus 0.08, since these are percentages, they all should add up to 1 or 100% in the end. And you can see 0.08 and 0.17, well, that's 0.25. So I've got 2 of those when I combine those, giving me 1, 2, 3, 4 0.25s. They all add up to 1, which is good. That translates to 100% of the data is calculated for in this relative frequency histogram. Notice the bin width is something you might get asked for. Well, the bin width here is just the length of each bin. It's going to be $50 is the bin width. And if you have this relative frequency histogram, now that you basically know the heights of all of them, you're going 40, 85, 125, you could transfer this into a normal frequency histogram if you wanted to, now that you have all that information. All right. The last thing we wanted to talk about really quickly is how the mean is related to the median if you know the shape of a data set. So if I'm looking at a histogram and I see something that is skewed to the right, so that's, remember, follow the tail, it looks like this. That's going to be skewed to the right. That means most of the data is sitting over here. So the median is likely going to be over here somewhere. But because you have these larger numbers over here, what that does is that pulls the mean to that direction. That means the mean is going to be greater than the median. So if a histogram is skewed to the right, then the mean is going to be greater than the median. And that works for a dot plot too. Now, what if it's skewed to the left? Let's draw a picture so we can get a better representation. So that's a data set that would be skewed to the left. Remember, follow your tail. That means most of the data is sitting over here. So the median is probably close, the middle is close to that data. But you have these smaller numbers here. And what's going to happen is those smaller numbers are going to pull the mean in that direction. So if you have a histogram that's skewed to the left, well, the mean is likely less than the median. Works for a dot plot as well. So that's all I have for bar graphs and histograms. You should be good to do the problem set for section 1.5 now. And then you'll be ready for section 1.6.